All right, standard 5.6 solving rational equations. And we're going to start with just jumping into it from the solution stations. Number one, this is something we learned in our past math history, that you'll notice this is one fraction right here equal to another fraction, also called a proportion. And we can take advantage of the cross product property in this situation. So I can take this 9, this numerator, multiply it by that denominator, which is x plus 2. And then we can take the numerator of 2, multiply it by, 2, and multiply it by x plus 1. And you can see why it's called cross product, as it makes an x. And we set those products equal to each other. Now it's just time to solve. I'll distribute. I got 9x plus 18 equals 2x plus 2. Now go ahead and pause and finish solving that, and then unpause and check to see if you got it right. All right, these x's are on different sides of the equal sign, so I'm going to zero out the x's on the right by subtracting 2x from both sides. So I get 7x plus 18. No x's on the right side now. And I'll zero out this 18 by subtracting 18. 7x equals negative 16, and the opposite of multiplying is dividing. So x equals negative 16 over 7. Okay, number 4 from the solution stations. I cannot use cross product here because I have two fractions on this side. It's not a proportion. I have two fractions. So what we want to do is we want to get a common denominator like we were if we were adding and subtracting. So what is my least common multiple? Well, the factors of this denominator are x plus 2. Factors of this denominator, x minus 2, gets its own column. And then on the other side, I have factors of x plus 2 and x minus 2. Which means if I take one from each column, my common denominator will be x plus 2 times x minus 2. All right, so my old numerators are 5 and 7, 7 plus 5, and we need to see what factor I was missing from this denominator right here of x plus 2, and I was missing this factor of x minus 2. So I need to multiply the 7 by x minus 2. On this other denominator over here, I'm missing the factor of x plus 2, so I need to multiply the 5 by x plus 2. And on the right side, we had both of those factors already. So I don't need to multiply 10x minus 2 by anything. And now what's great is my denominators are the same. Therefore, the numerators must be equal to each other. Logic just tells me that. So I have 7 x minus 14, because I'm distributing the 7, plus 5x plus 10 equals 10x minus 2. Now, here's a mistake I want us to avoid. I've seen so many students do this in the past. They'll just quickly go through. They're not really thinking. They're just writing. And what's wrong with this? Where's the mistake? The mistake is they have subtracted 5x on the same side, and they haven't done the same thing to both sides. It's not balanced. So here's what we want to do. Let's go ahead and finish on this left side, combining my like terms. So I've got 12x minus 4 equals 10x minus 2. Now let's zero out the 10x on the right side Whatever I do to one side, I do the other side. Gives me 2x minus 4. Let me write this better, excuse me. And then I'll zero out the negative 4 by adding 4 to both sides. As it doesn't have x, I get 2x equals 2. And when I divide by 2 on both sides, I get x equals 1. And the only thing I'll add to all this is if you get to any point you're solving and you've got a situation where you're stuck with unlike terms, x squared minus 3x equals to 10, if that's the case, we need to get this equal to 0, and we can solve by factoring. We've been practicing factoring a whole bunch here. So what multiplies to be negative 10 and adds to be negative 3? Well, that's negative 5 plus 2. And so my solutions would be 5 and negative 2. All right, there you go. You can say what you learned and get on to the practice.